in this question, as you see, the two different masses which are attached with the same string, and that string is passing over a frictionless pulley, which means that you have to ignore any rotational motion of this pulley. Okay, and by analyzing this question and solving the equation simultaneously, you have to find the ratio of the masses in this question. Okay, so let's try to solve this question. And first of all, uh, the first step, as you know, in a forces question is always about the free body diagram, and I'm going to draw the free body diagram. So how many forces are exerted on this mass m1? Okay, but before that they are stating it that the mass m2 is accelerating where? It is accelerating down at a g by 2. So if it is accelerating down g by 2, let's say negative g by 2, because that's a acceleration is a vector quantity. So m1 must be accelerating with the same magnitude but upward. And why I'm saying it? Because both masses are attached with the same string. And second important point, as you see in a diagram, both masses are attached with the same string which is passing over the pulley. So we know that when the two masses are attached with same string, so there is a same force of tension that is originated, that is produced at the both ends. Same force means their magnitude, okay, not necessarily the direction. Okay, there will be the same magnitude of these two forces. So that's why when we will draw the free body diagram of these two, so then you must draw the same length of upward arrow. Okay, like this here, this is a force of tension, so I'm going to draw here also the same length of arrow, that is a force of tension. But because you know the m1 is accelerating upward, that's why in this free body diagram we should draw the smaller arrow for this. So m1g. Okay, so what is the resultant force from the free body diagram? Now we can write an equation. So ft minus m1g is equals to m1 times acceleration, and acceleration is g by 2. Okay, well, you can solve it also, and if you take it on the other side, so it will be add up into the other side and it will be this one. All right, and it can be written as 3 by 2 m1g. This is a relation between the force of tension and weight of the mass m1. Okay, now let's talk about the free body diagram of the second block, which is accelerating actually down. All right, so it means that its weight must be bigger, m2g. So you can also write this equation directly. m2g minus ft is equals to m2 times acceleration, and I can write here g by 2. You might be thinking why I have not written negative sign, because I skipped one step. Okay, and that step is this one. Okay, m2 into negative g by 2. So it will once again become the same thing. All right, dear students, so if you take this thing to the other side, and it will be m2g minus m2g by 2 is equals to force of tension. So what is the relation between the force of tension and the weight of the second block? You can see a full and minus half of this weight will give what? m2g over 2. Okay, students, so now can we relate these two equations? If we equate them, then we can easily get a ratio. So if you equate, so 3 by 2 m1g is equals to m2g over 2. All right, so g and this g is cancelled out, this 2 and 2 is also cancelled out, and finally the ratio of this masses is 1 over 3, which means the right answer must be option A. I hope you understand this question.